And good morning, all my caffeinated squirrels. So it seems that the game we're playing today is a competition of who has the worst weather right now or the nicest weather right now. Nobody wants to be, oh yeah, mine's okay. It's kind of average. Oh, 1 second. Do I have audio? It looks like I do. I think it's okay. I think it's okay. Okay, which means I acknowledge the traditional owners of this land, the Whadjuk Noongar peoples. I pay my respects to their elders, past and present, and to Aboriginal elders and peoples from other communities who may be taking part in this live stream today. Yes, good morning. Chris says, happy Saturday from USA. Hang on, I do not have TTS going. That was something that I forgot to load before the stream. So now I've got to log in and get the list. I didn't realize until I started looking for the list of people to say hello to. Amanda, I'm here but have to duck up the road, be back in 30 minutes. Okay, Amanda, we'll just pause the live stream for the next 30 minutes. And okay, I'm going to freeze right now. My hand was still moving a little bit. Okay. Stephen says, a balmy 5C here. Yeah, it was driving to the lab this morning. My car popped up a frost warning at 2 degrees and then it dropped down to 1.5 degrees. It's hello in Cali, Canberra now. Okay. It's, just a quick scroll through chat. I'm not sure if I've missed anything, but anyway. Yeah, the members list, it's caught up. Okay, so good morning to Matt W, Mitch, Stephen W, Scott Miller, Chris Davis, John Whips, Simon, Stephen George is here, Crispian is here, some call it fun, Blue Man 74, David C, Tabraze, Imi is here, Any Mules, Russell, Technebulis, Amanda was here, but has gone up the street for half an hour. Mark Laguda, 8 degrees Celsius and beautiful sunny morning in Ballarat. And Cassio is here too. Good morning, Cassio. Yeah, I like when the air is cold and the sun is warm. That is a really nice combination. Clifano, I haven't seen that name in the chat before. Clifano Subagio. John, were you at OSDC Canberra back in 2011? I believe I was indeed. Yes. In fact, I gave a talk. My memory is hazy back there, but I'm pretty sure I gave a talk. My throat is really not good. At the dinner about 3D printing and weapons. So that was what, 14 years ago? Okay. I need to take a swig on this. Maximum caffeination for the squirrels.
Miller said, air is hot, the thunderstorms have been here most of the day.
Oh, thunderstorms. Yeah, that was a weird one. I think that's the only time I've given a conference talk that was at a dinner. I can't even remember the circumstances around it. It was like kind of a keynote, but not a keynote, something like that. And it was around the time that that DIY 3D printing was becoming more of a thing and people were kind of freaking out about the idea of 3D printed weapons. Alistair is here as well. Okay, so Don S is here, and sorry, I'm just marking names off the list. Roll call. There we go. all caught up. Now, right before doing this stream, I just jumped on shitter.com for the first time in a little bit and posted because I wanted to post a link to the stream.
Henrik Ostrov said, finally managed to catch the live only when in badly ill still, but getting better. Let's just say I have a lot of stitches and bruises, both legs and right arm. Don't play with gunpowder.
What? Now, this is a story. Come on, this is a story that you absolutely have to tell. There is no way you... I'm just going to go back to this. All right, I'm going to hit play on that message again. Here we go. Here is a 9-second clip.
Henrik Ostrov said, finally managed to catch the live only when in badly ill still, but getting better. Let's just say I have a lot of stitches and bruises, both legs and right arm. Don't play with gunpowder.
No, don't play with gunpowder. And Henrik, what the hell? That's the only thing I have to say about that. Actually, no, I have a whole lot more to say about that. But what were you doing with gunpowder that then involved you requiring stitches on, have a lot of stitches, and to have bruises on both legs and your right arm? You've got to share that story. You have to. Okay, now where am I? I'm going to switch down to here. Scene transition. My Stream Deck is not working today, so I'm using the web-based button control panel in Companion to flip to this. Now, that's right. Just before Henrik started his tale of woe, that big teaser. Oh, Austin is here as well. Awesome. Half awake. Well, maybe you will fully wake up when I start doing conveyor things in a moment, because I am sure you're going to have some things to say about it. Yeah, so I got onto excuse me. I got onto Twitter in order to post that the stream was happening, and so Joseph Chu, you should follow if you're interested in this sort of stuff, at Toy Builder on x.com. Yeah, he posts interesting electronics related stuff. And he posted this picture which says, not sure what I think about it, simultaneously fascinated and a little bit disturbed. So this is a board layout, obviously. Let's zoom in on it a little bit. This is an awful lot of match length traces, like a pretty freaky number of them. I don't know how many layers this board is. It's a little hard to tell from here. It's a few. Let's just say it's a few. Yeah. And so what you see here, you can see lots of pairs of lines, and at first glance it looks like a single trace with a border around it, like with a polygon ground pour or something. But no, these are all pairs of traces. So if we zoom, can I zoom? Why can't I zoom? Oh, that's okay, that's as far as it's going to let me zoom.
Henrik Ostrov said, let's just say a copper pipe can't remember the size, but it blew apart to dust, I think. Also, a few days later, we discovered a small window had a big hole in it, that's all. Outside the box said, is that trying to maximize RFI?
Okay, so Henrik, homemade explosives. That sounds scary, whatever it was you were doing. Gunpowder inside a copper tube, a copper pipe. I don't think you should be admitting to that, not in public. You will have people wearing dark sunglasses knocking on your door if you own up to playing around with that sort of thing. So, firstly, stop hurting yourself. Secondly, don't attract the attention of the authorities. All right, so you can see here, for example, these are length matched. There are some interesting features in this board layout. You can see there is a pair here where my cursor is up towards the sort of top left. It's going beneath a through-hole electrolytic capacitor. You can see that there is one trace here that goes straight, the other pair that's next to it has this little wiggle in it to make it take a longer distance to travel to the same endpoint. So this is length matching on traces, so that signals that are on those traces arrive at the other end at the same time. Like the voltage differentials and things all match. So you don't end up with timing problems. Because the speed of light is a thing. The speed of light is very, very fast, but it's also simultaneously very, very slow. When you're dealing with, picosecond timings and things and signal transitions at very high speeds, the length of the track matters. So if you have two tracks, you've got to make them the same length. And if they bend around, then the one that's on the inside of the curve has to do some jiggles in order to make it the same length as the outer one. So yeah, you can see all these little jiggles, but just look at the strangeness of it. I don't know if this was done, well, it's got to have been done by a combination of human and auto router. This is like next level board layout insanity. So yeah, I think this is a situation where someone has been manually driving the auto router, if that makes any sense. So what you do is set up the endpoints and parts of traces, and then you allow the auto router to complete traces. Oh, you can see here that there is a trace that comes down here. This pair of traces loops all the way around here, trying to make it longer so that that pair presumably can match this other pair above it, which also has these big loops in it. So it's not just, it looks like it's not just matching within a pair to make the pair the same distance, but pairs of pairs or multiple pairs are being length matched as well, with these large meanders to try to increase the length on some tracks. Yes, Henrik. Henrik says, I know it has to be like that, but it's kind of looks to me like drawn by a drunk humanoid. Yeah. Scott says, plot twist, those are all DC signals. Yeah. Crispian says, surely they'd have been better off trying to get the large components closer to one another and shortening the tracks. I don't know. This sort of level of design is so far above my pay grade that I... Oh look, yeah, and what we're looking at is just a corner of the board, obviously. There's a BGA down here. Look at this.
Austins_creations said, feel free to look at Discord's board design channel. I've been catching up on quite a few projects lately.
Ooh, nice. Okay. Thanks, Austin, I will. Yeah, look at this. The way they've had to route all of these signals out from under this BGA, this collection of signals, it could be HDMI or something, like or a multi-channel, like say it's, at a guess, it could be something like PCI. So then you've got many data channels in parallel and they all have to be length matched for very high speed signals. But yeah, look at the strangeness on these tracks. So we've got all of these pins, or pads rather, balls on the bottom of the BGA that are being mounted, that are being routed down through vias onto lower layers, obviously, because you can't route out of a BGA without things like, and also you can tell that they're using...
Henrik Ostrov said, I never saw how do you make tracks same length by hand if it has a lot of turns and so on.
Oh yeah, doing it by hand, that's a total pain in the ass. I would only ever do it with an auto, like an auto router sort of thing, where the tool does length matching automatically. And you can do, like, all of the decent PCB layout software can do that. KiCad does it, Fusion does it, of course LTM does it, all the high-end stuff does it. So you just select, you define a pair of tracks, and then when you're routing, you're not just running one track, you're running two tracks simultaneously. So as you're moving the cursor, two tracks are following where you go. And it automatically adds little squiggles and things into it to keep the lengths the same as you go around corners too, which makes them different lengths. But this is some seriously interesting stuff here. So you can see these signals routed out from the bottom of the BGA coming up here, and then there is a whole lot of meandering here, like macro meandering to make the overall pairs the same length. Big meandering up here in this central area. So these are the tracks that are on the inside of the curve. What we've got here is tracks curving from this point and generally going up and then left and then down again. And what that means is that the tracks that are on the inside of the curve have less distance to travel. So to make them all match the same length, you have to add these meanders to them to make them longer. It's like having slot cars and you want all of the slot cars to travel the same distance, and so therefore you have to make the inside lanes do some wiggles to make them travel further. But that is, yeah, the more I look at this, the more impressive this is. This is really serious, serious timing control on these tracks. Don said, what did I miss in the last 2 weeks? Ooh, hang on. Alistair sent a link. He said, check out the placement on this board. Somebody sneezed. Orange pie. All right, I'm going to open that link. Oh, it's opened in another window, so I'm going to... Oh, yes, this thing. Okay. Look at this board. Oh, and the strange placement of these. So my guess is that, well, that's the main processor, the H5. My guess is that these are memory chips, probably flash memory or something, or maybe DDR RAM. They could be. What does it say? Oh yeah, they are. Here we go. It says 1 gigabyte DDR3 RAM. So these are RAM chips, Ethernet chip, and yeah, H5 quad-core Cortex 64-bit processor. That's a very seriously powerful little device for a Raspberry Pi form factor. Yeah, it does look like somebody sneezed, Alistair. Donna said, is the keyboard complete? Okay, I will get onto the keyboard in a bit. Short answer is yes. I still need to do a little bit more on Andrew's keyboard, but that is effectively almost complete as well. It's usable right now. I just want to do some more firmware stuff on it. Yeah, so Joseph's comments, where are we? Oh, LinkedIn feed there. This is one length tuning method I hadn't seen before. I've done little jogs before entering a pad, but not circling around most of the pad for extra distance. Yeah, because of the zoom in, it's a little hard to see here because of the pixelation. But if you follow my cursor, which is just above my head, you can see this track comes in here, goes between these two pads, jogs up and then down, and it traces all the way around here and then joins into the pad here. So the shortest path would have been to bring the track in from here and then straight across and join the pad. Right there. But instead of that happening, it goes up and then down and around and then joins in on the back side of the pad right here, just to get an extra couple of millimeters of length on the track. And the same thing's been done on all of these pads. Pretty cool. Oh yeah, so the zigzag routes were hints that they were considering the weave. Yeah. So the purpose of running the wires at odd angles is to avoid running high-speed lines along the fiber weave. The glass fiber weave of the PCB gives it slightly anisotropic electrical properties. So if some lines are versus not aligned, there could be a signal integrity or impedance matching issues. Running them at an angle tends to ensure all of the lines are crossing fibers randomly. Some Intel platform reference documentation specifies that PCIe or Thunderbolt should be run at a certain angle to the fiber weave. That is nuts. So that is some of the explanation for this zigzag shape up the top here. And what we're seeing here is just one layer, it looks like, has been selected. And look, there have been red arrows drawn in here to pass it around. We hit the milestone, feel the energy. Henrik! Thank you, Henrik. And I'm happy for you to have been a member of the community. Yes, thanks, Henrik. So we're looking at one layer has been highlighted, but there are many, yeah, ruined by me. That's exactly it, Mitch. You can see there's another layer down there which is slightly grayed out. There are multiple layers stacked on top of each other here. I don't know what this board is, but it's likely to be something like at least a 12-layer board. It could be significantly higher than that, I don't know. We just don't know what layers have been turned on or off. Let's have a look at, I haven't actually followed this.
Said, we used to orient the circuit at 45 degrees in the panel to do the same thing to get consistent transitions over the fiberglass weaving.
Oh, okay. Orient the circuit at 45, yeah, okay. To get consistent transitions over the glass weaving. I've never worked on a design, oh, look at these pictures, these are just beautiful. I've never worked on a design where I have had to care about the interaction between the copper and the fiberglass weave. That is definitely way above my pay grade. Oh yeah, look at this. This is a work of art. This is the one that we were just looking at. That is very hard to see, but it looks crazy. This one also. Ooh, let's see if we can zoom in on it. Yeah, we don't have enough resolution to really know what's going on with this. We can tell some things, like that's obviously a USB socket there. That's a USB-A socket, like a Type A. That's a USB Type C. This would be possibly micro HDMI. There's an SD card there. That'll be an Ethernet connector with the LEDs. You can see the LED pins on there. Various headers around the edge. I/O header up there. What's on the right here? Connectors for something. Don't know what. Yeah, and then a big ass chip in the middle here, which is probably a BGA. It is actually really hard to tell from this. Don't really know. Probably a connector here for like an M.2, so there could be a memory module, like a storage module on there. Power supply is down in this region. Yeah, you can kind of tell a lot just by looking at a PCB like this. You can, yeah, once you've looked at a few boards. Oh, there's an antenna connection up there. Yeah, you can tell a lot from the PCB.
Said, what connector was down left corner?
Down left corner, this one, that's just a power socket, like a DC power jack or something. Feeding into here, there's a diode. Looks like some decoupling caps, bulk decoupling. This will be a voltage regulator up here. That'll be something like a switch mode power supply in there. So this left part of the very left edge of the board up here, apart from the connectors, that looks like it's all power supply on that side. What else have we got? Don't know. Anyway, it's fun looking at other people's boards and learning. Learn from the experts. So that's very cool. I Oh, yes. So something else. I'll get to keyboards in a second, and then I will get to the actual project stuff that I want to work on today. Yeah, that is so cool. Anyway, go and follow @toybuilder on x.com. Yeah. So he posts interesting stuff. There's what is this? Oh, one of the benefits of a medical cart, aka a cow, computer on wheels. You can float your scope on a UPS so you know you don't have a ground loop. Not portable like a USB-C powered oscilloscope, but this works well enough. Medical cart.
Twitter.
That is cool. Twitter? No, I say it's... no, I generally call it shitter these days because it's Xitter. Yeah, medical cart. That's cool. That is really cool. Must have been like a bit of secondhand medical equipment or something. Medical stuff is always really super expensive because of the certification process. But it can be handy. So oscilloscope on a medical cart with a UPS. Total electrical isolation. Very good. 2 decades now. What project? Unearthed while looking for some other parts. What are these? AT89C52 24AC, 24 megahertz. IC micro, 24 megahertz, 44 TQFP. Can't quite tell what they are. Microcontrollers, I think.
Henrik Ostrov said, "Is your oscilloscope on ups as well to get rid of ground loop?"
No, it's not. It's the scope. My current scope, my main scope now, is a Rugol DHO924S, and it is powered off USB-C, which is interesting. It comes with a mains to USB-C power supply, and I've got to admit, I have not even looked into what its isolation is. I don't know. 15-minute PCB milling job. Yeah, looks like Joseph has been milling PCBs. Oh, yeah. Homemade PCB with a little short in there. Right, anyway. That's right. Okay, another squirrel. And this squirrel is going to be transporter. So those of you who are on Discord, I will have already been telling you about this. So I want that. Hang on, I'm going to open a couple of things and then I'm going to drop some links in here. Space launch schedule. Is it that one? I'm just looking for some links. Okay, here we go. This should do. So, upcoming launch. It's going to be tomorrow morning, my time. It was meant to be yesterday morning, and then it got bumped to this morning, and then late yesterday it got bumped to tomorrow morning. Okay. Now, I don't... where are we? Sorry, I'm looking for things on the other screen. Now, where is it? Robinson Aerospace. This is Robinson Aerospace. Here we go. Now, there are 2 reasons that I care about this particular launch. also bringing up, so that and that. So, oh no, I can find a better link than that. Yeah, this one will do. Okay. Why isn't Robinson Aerospace loading? Oh, there we go. Okay. So let's just dock a couple more links here. When I was in Adelaide in January with many people, but specifically I travelled with Angus. So my friend Kelly introduced me to the owner of Robinson Aerospace, and I've told this story already, so I won't go into it in great detail. Anyway, Robinson Aerospace have a CubeSat which is on that launch. Oh, there he is. There's the owner. And where is it? RASCube, RAS launch. Maybe there's some information here. Yes. So they have built a this thing. So RASCube 1 is going up on that launch. So this is one new CubeSat which is being. So my understanding is that this is staying attached to an overall structure, and it is not going to be deployed on its own into its own unique orbit. And which, yeah, but super cool. So I'm really happy that they that is happening for them. And the other thing, I've just got to redock some tabs here. The other thing is on that same launch is CyanoSense 2, which is this is old information about it. This page was published a while ago. As you can see, it says the team are starting to develop the next iteration of the CyanoSense payload. So this is a couple of years ago. And CyanoSense 2, the actual satellite, is now on this rocket. It's on Transporter 14. And a couple of the boards for that were assembled here by me and Tommy. So that is really cool. So anyway, even though that assembly job was, let's just say, tricky. It was very, very hard and a scary assembly job. But yeah, so Stephen W says hopefully it doesn't do a Starship. Yeah, I hope it doesn't do a Starship. So CyanoSense 2 and RASCube 1 are both on the Transporter 14 mission. And the live stream will be starting 7:04 a.m. tomorrow in Melbourne time, and the launch I think is at about 7:19, something like that. Yeah, so they start the stream 15 minutes before the actual launch time, so they give you a little bit of briefing leading into it. And oh, hang on, I want to. So I'm going to drop this in the chat. Transporter 14 launch. Actually, I'll just drop the URL in there. That'll do. You'll know what it means. So tomorrow morning, I'm going to be watching this launch and hoping that we do not get a big kaboom, because that would make me very, very sad. And it would make Ed very sad at Robinson Aerospace as well. So yeah, hopefully Ed's CubeSat will make it up into space. And oh yeah, so this is the other cool thing about this. The Robinson Aerospace is all about educational science and space stuff. So 7 schools 7 schools from 7 countries. High school students from Rwanda, Ukraine, Colombia, Singapore, United Arab Emirates, USA, and Australia have collaborated to design, manufacture, and launch their experiments into orbit. And that photo is of the student team from Colombia. RASCube 1 integrates a number of projects and a number of experiments that are being done on behalf of the school students, which is brilliant. That's a really cool initiative. So yeah, I'm really I'm really chuffed to see them doing so well and all of the progress that they've made with developing their CubeSat program. Oscar said, I learnt not to watch SpaceX launches on YouTube anymore after getting 15 minutes into an AI-generated loop of Elon hawking a cryptocurrency scam. Oh no. AI being used for evil. Henrik says, hope your assembly can withstand this acceleration. Yes, so do I. That is, yes, I really hope it does too. It's been vibration tested, like all integrated. It was integrated at, what's the name of that aerospace company in Queensland? The one that was doing the rocket launch recently. For some reason, like Queensland. Gilmore, that's it. Yes, Gilmore. So Gilmore Space, G-Space. Gilmore Space in Queensland is the company that has been doing the integration of all of the components that go into the Science 2 satellite. So they have taken care of all of that. Have you ever noticed that all rocket company web pages are black? CSIRO is not, but that's CSIRO. But yeah, they all have this black aesthetic. Darkness. The blackness of space. So, yeah, RASCube workshops. In-person workshops. Yeah, these RASCube things are very, very cool. Essentially, what Ed is doing with RASCube is what I hoped ArduSat would become. And then it ended up taking a detour and turning into Spire Aerospace and became a commercial Earth observation platform. Rocket Lab, says Don S. Oh, that is, yeah, Rocket Labs. Yeah, that's the New Zealand.
Sure how to help
Alexa, stop. I better hit the mute button so it stops listening. Which reminds me, one of the things I want to follow up on is I still have a couple of those voice assistant devices to play with, to experiment with local privacy respecting voice assistants. Wagon Light says, since dark mode came out, I can't go back. I think that's a sign you're a vampire. Rocket Labs. All right, let's see. Rocket Labs. Rocket Lab, space company. Yeah, okay, so this is Rocket Lab. And then Gilmore. Yeah, so here we go. Gilmore Space and their aesthetic. Rocket Lab and their aesthetic. Robinson Aerospace and their aesthetic. SpaceX. See, it's all dark mode. 100% dark mode. Yes, could we see the devices, says Henrik. Are you talking about the Cyanosense boards? I don't physically have them. They're worth a lot of money, and the ones that were assembled we assembled basically. Irfan said it's borderline the same font too. So we assembled 2 each of the flight ready boards there, and then they both went through all of the testing and validation, and then one of each of those boards goes into the actual flight hardware, and then the other identical ones are kept as flight identical hardware here on Earth, so that there is a reference of the hardware. I don't have any of it. Scott says someone needs to start a rocket company just to create a neon themed website. Yeah, maybe. Oh, Andrew said, taught my mum how to feed the cat and set a timer with my Home Assistant voice preview device yesterday. Oh, nice. Yeah, so one of those Home Assistant voice preview devices is what I have. I've got one of those and one of something else and some other bits and pieces. Oh, Henrik said the Alexa stuff. Yeah, we'll get to that, but not on this stream, because that is going to be a whole stream in itself. I'm already 45 minutes in. I have not even begun to touch the actual topic of today's stream. So, yeah, I probably should get to that. But first, a quick update on keyboards. Yeah, how am I going to do this? All right, I'm going to... Where? Okay, keyboards, where is the other keyboard? All right, I'm going to start by... I'm just going to show you keyboards, and then I'm going to get into some Conveyor stuff. But to show you the keyboards, I have to get... Oh, Andrew is down from here. Is it in here? Yes, it is. All right, so this, that way around? Yeah. So this is Andrew's keyboard, the Pancake Legend keyboard, or PLMIT60, I think it is the actual name of it. You can see it's ortholinear, so it's a proper grid. The columns are aligned and the rows are aligned. It's a straight up grid. It's a fairly minimalist sort of design, so there's no number row, there's not a lot of anything actually. It's just the things you actually care about. The way the default key layout is set up. Oh, I didn't have a blank double length key, so I used the 0 key. The keycap set that I got, this is all Cherry MX Browns. The keycap set that I got had a double length 0, which is used sometimes on numeric keypads, and so I use that as the spacebar. So that 0 is the spacebar, and then the two beside it, whoops, wherever it is, that one and that one, no, that one, they are the raise and lower keys. So these are to get to different overlays. So if you press and hold that one, all of the key definitions change. So that gives you access to numeric keypad and other things by holding that down with your thumb. Yeah, in terms of a layout, this is not a layout that works for me. It doesn't have enough keys on it. I want the dedicated number row, and I want various other dedicated keys as well. So it's too small in terms of the number of keys, and also I prefer the split layout. But still, the build quality on this is incredible. Like that, when I say the build quality, I put it together. I mean the design quality. The thought that Andrew has put into designing this with the steel plate in the middle and the sandwiched PCBs and everything, it just feels beautiful. You put it on the bench, it's very thin, like low profile. It's just a pleasure to type on. Really, really nice. So I am very impressed by this. The reason there are a couple of keycaps, whoops, almost had an accident. The reason there are a couple of keycaps missing is that I did not have keycaps in the set that match these. This one here is tab, and the only keycap for tab that was in the set was a double width, I think, or a 1.5 width. I can't remember. Something like that. It was anyway, there wasn't one that matched. And this was enter. Is it enter? No, it's not enter. That's right. The other one thing you might notice on this, there is no enter key. It does have dedicated arrow keys, which I very much appreciate. I like this, but there is no enter key. That is not enter. It's something else. I can't even remember what. And the way you press enter is you do, I think it's it's left modifier and space. So when you go to mod 1 and it it remaps the layout, it changes the space into an enter key. So to do or is it, yeah, I think it's the left. So if you want to type enter, you do left thumb down and then tap with your right thumb. So yeah, there are a couple of things like that that are kind of awkward with that keyboard. All right, now I'll show you, to show you the other keyboard. Where is the backspace key in there? Oh, there isn't one. Yeah, there's this. Oh, Irfan said Alice layout is the way. Oh, Alice layout. I've got to check that one out. Yeah, there are so many layouts. So this is, yeah, this is very minimal. In terms of keys, like number of keys, there are a couple of philosophies. One philosophy is to minimize the number of keys by adding dimensions, extra layers, so that you switch to a different layer and then you got access to a whole different key map. That is harder on your memory, but easier in terms of finger movement because you're not moving as far. The alternative is that you don't have multiple layers and you have many more keys so that you have dedicated keys for everything. And that means you've got a lot of finger movement, but you don't have to conceptually switch modes or layers, which works better for some people's brains. So most keyboards are a combination of things, like a midway point. I don't mind having layers, but I don't want too many layers. And this particular keyboard layout, because it's called a 60 key keyboard, but it actually doubles up on the space bar. So I think technically it's 59. Is it? I don't know. I haven't stopped to count. It's 4 rows of however many columns. So -1 for the double width space bar. And yeah, Alastair says Optimus style OLED keys for dynamic overlays. That would be really nice. Wagonload says, what about a court reporter keyboard? Yeah, that is the extreme, where it, like a courting keyboard, combinations of keys for everything. That takes a special type of brain and training. So, and also those are very much tied around phonetic recordings. So it's recording the way things sound. Not so good for programming, better for just like recording a stream of consciousness. Yeah, really, really nice keyboard. And I've got this working now. If I plug this in, it works. It's fine. I've got the firmware loaded on the Arduino Pro Micro. The key layout that you see there is configured. It's all set up. It all works. It's just that this is a regular QWERTY layout, as you can see, and I would prefer a Dvorak layout, and also more keys, and it's straight. So it is not the keyboard for me as a daily driver, but it is a beautiful keyboard. For people where this sort of style suits them, this is a work of art. It's really, really nice. Now, I'm going to show you where I have got to with I'm gonna have to move this, and it's blue tacked down. How am I going to do this? Okay, got to unstick it from there, move it over here, and go to overhead camera. Okay, move those out of the way. So this is where my soft play chock has got to. It's not plugged in right now. Normally there's USB plugged in here. I just unplugged it. The two halves of the keyboard are joined by this cable, which is it's actually a microphone cable from it's a Rode radio microphone cable. So I normally have it at an angle that is something like that and at about that distance. And I have the space mouse in the middle here. Although actually I normally have it slightly further apart. Something like that is about my normal position. Oh, you can see the microscope in the way. Move that out of the way. Oh, fume extractor gives me even more space. There we go. Now you can see it properly. So somewhere about there is how I would normally have it. So with my hands resting on it like that. You can see the M1 key down there, that's a mod key. It's Dvorak layout, so you can see under the left it's all the vowels, common consonants under the right. I think normally it would be QWERTY up here, like Q, W, E, R, etc. But I've got punctuation there instead. I've got a couple of interesting things about this. One is so it's got these rotary encoders. You can click them in or you can turn them on both sides. I've got down here, you can see page up, page down. They're not actually page up, page down. That's up arrow, down arrow. But I almost never need these. I use these when I want to reach across one-handed to press up arrow in a terminal, like up arrow, enter, in order to rerun a command. But this rotary encoder sends left and right key press events. So I can scroll on a line with that, play, pause. So I can scrub through videos by turning this knob, play, pause videos with that, mute with the right knob, clicking it in, and volume with the right knob. What else? Oh yeah, that's right. So modifier. If I press down M1, it remaps all of the keys, and then I've got navigation under the right hand. So if I hold down M1, where is it? There. So is this? Who's here? Is that Johnny Bergdahl? Yes, Johnny is here. So this is navigation. There is an upside down T here. So that's up, down, left, right. And then I've got start and end. And then that's page down and that's page up. So just by pushing down with my left thumb and using these keys here, I can navigate. These are my arrow keys. And because it's the inverted T is naturally under my default finger positions, that works really well. So I can just press that and do this. I've changed a couple of things over the way soft plays are normally set up.
There is two USB connectors. What happens if you plug one USB into one computer and the other USB to the other computer, then also join together?
Yeah, then it has a bit of a problem. The way this works, the same code is loaded on both microcontrollers and they communicate over a serial. So this provides power and serial. USB comes in here, which provides power and USB to the first microcontroller. It then communicates over serial and provides power down here to the second microcontroller. And key press events on this one are passed through to this one, which then reports them to the computer. And the weird thing is they are running identical firmware with the same key map. The exact same key map on both of them, but they're only connected to half the keys each, and it all figures it out. Now, one thing is that if you look at the SoftLay keyboard layout, normally that will be space and that will be return or enter. and then normally there is something else here, like normally that is mod 1 and that is mod 2. So I've changed it around. I've got, and I found that this just works better for me, because with my default hand positions, my left thumb is like, with your left thumb there, that can be the default if you've got space there or there. And I find that for my hands, it just works better if the second button in is the default. So that's enter and that's space. So I can type like that and hit enter with my thumb. And then I reach across if I want the modifier, and I reach across if I want back. So what is that car? Wonder if you can hear that. And having it in this order on the left, see that's back, space, and delete. To my mind, that makes sense, because back is left, space is like adding a space in the middle, your current location, and delete is to the right. So it's like left, center, right. So conceptually, my brain maps that really well. Like if I want to go back, it's there. Add a space to my current location, it's there. Delete forwards, it's there. So that maps nicely. And enter there. I have a little bit of trouble so far still with these keys here because of the columnar nature. I often find myself hitting K when I'm trying to type J, just because on a normal keyboard they're all shifted across, but I'm getting used to that, so my error rate is decreasing with that. So anyway, that's the summary of the keyboard. I want to get on to doing some other stuff. Someone is being quite noisy out the front there. So switching back to my regular position, move the keyboard back into its thing. Oh, these, I've stuck it away now, but yeah, someone is being quite noisy. These keys, Stephen, it's now 11, you may start the first topic. Awesome, thanks. Now I'm going to just bring up something, one final little thing. I have, this keyboard, where are we? Here we go, bring this up onto here, max screen it, get rid of the origin. This is the base that the keyboard's sitting on. This is the right hand side, and you can see, so what I did was I found an existing keyboard base design, which was just the top part of this deck. It was the outline of the PCB and the little border around it, and the idea is that it sat flat on the desk, and it had a few holes in it for mounting screws and things like that. So I then modified that to add this wedge on the bottom, and the wedge is angled so that the keyboard is tented. It's higher in the middle than it is at the end, and it is higher at the back than it is at the end. So you can see it's got like this like a diagonal wedge that sits under the keyboard, and then the left side is just a mirror print of this. Speaking of which, I now have an X1C printer. Amazingly, one of my clients bought an X1C a couple of weeks ago, like 2 weeks ago, and then and I've been doing some design work for him and sending prints to his printer, and he loves it so much that he said that, like, after having this X1C for about a week, he said that he regretted not getting the H2D, which is the even bigger, the huge new Bamboo printer. So I ended up doing a deal with him where he then ordered the H2D, and I am buying his X1C from him, which is now all of 2 weeks old, and it's sitting on the bench back over just inside the front door. But yeah, I've had his H2D here for the last few days, and I've been printing stuff on the H2D, which is a ridiculous printer. It's incredible. Hang on, I actually took a photo. Did I sync? Just checking whether I synced photos from my phone. Let's see, Dropbox. I'm going to show you this this printer because it is ridiculous. Camera uploads. Okay, it's in the process of syncing. Getting there. Okay. Oop. What was that? Oh, I've got a delivery. Hang on. I don't want to miss this. Good morning.
Good morning.
Great. Thank you.
Thank you.
See ya. I heard the little "ow" sound from the front door, and there was a delivery guy standing there. Where are we? Here. Okay. Opening it. This is the H2D that was sitting on the table just in the front of my office area up until about, what is it now? It's 11. Up until 2.5 hours ago, this was sitting just inside my front door. You can see it's got the AMS2 Pro on it, and I used this to print the bases. I actually ended up printing several iterations because I printed one that didn't have this front to back angle on it. It was just tented towards the middle, and I found that the back keys it was too flat. I needed the back keys to be raised. So that was when I added that the angle cut along in that direction as well, and then printed a couple. So the ones that my keyboard is currently mounted on were printed. Come on, can I switch?
Austin_creations said, "I'm surprised that after all the streams that this is the first delivery on stream, but also are you gonna leave us hanging on what it is?"
Oh, it's not that exciting. I think it's just anti-static bags. But Austin, you got to keep in mind, when I stream, it is Sunday morning. So deliveries on a Sunday morning. So this is I was about to lift it up and possibly dox myself. So this is the package that arrived. I will open it just to satisfy your curiosity. But yeah, it is just anti-static bags. What I'm really hoping for is a delivery of some 050 motors for the conveyor belt project. And yeah, where are we? Here. See, just anti-static bags. Not that exciting. Not thrilling at all. It's one of those cost of sales things where I need bags to put devices in, put boards in when I send them to customers. Speaking of which, I've just been experimenting with cardboard boxes for customers' boards. But hey, let's not chase that squirrel right now. So I've got a whole lot of boxes with labels and things on them. Anyway, the point is, it's hard to get a sense of scale of this printer just from looking at it from a photo like that, but it is friggin' huge. So the printer itself weighs 30 kilos. What is 30 kilos in pounds? It's like 70 pounds, give or take, something like that. So it's a pretty solid beast. It's got 2.5 times the build volume of an X1C, like the standard sort of printer. And the build plate, when you pull it out, it's like, it's huge. It's ridiculous. But it is such a nice printer. The level of polish on this, and you can tell, so the X1C is a nice printer. It really is an appliance that you plug it in, you load your designs, you hit print, it figures it all out, and it works. They're really, really nice. But this, you can tell that the H2D is like, it's a supersized X1C, but with a couple of years worth of polish. It's just, and the thing is that when I was talking to Daniel about this, so Daniel's my client that actually owns this printer. When I was talking to Daniel about it and trying to describe how this is better than an X1C, apart from the size, it's not that you can't really point to one specific thing and say it's better because of this. It's like a whole lot of little things, all just tuning. It's all just extra polish. Nice things they've thought of. Refinements all over the place. It's just such a nice printer. So yeah, anyway, I've had one of these sitting, well, as you can see, right there on the bench just inside my front door since late last week. And I've been running that. Oh, it's also astonishingly fast. So you can see the Benchy sitting there on top of it. That was one of the preloaded models. And when we started at printing on Friday, Tom and I set it up. And on the touchscreen, we just pulled up, Benchy, print, and then just sort of stood there watching it. It's like watching a time lapse in real life with the head going, Jeet, and the boat just sort of appearing out of the print bed. So the experience of watching a time lapse of a 3D printer, it's like having a time lapse in real life. Very, very cool. Wagon Load says, someone on YouTube made his own 3D printer almost big enough to park a car inside it. Was that, what's his name? There's the guy who did the 3D printed tank a few years ago. And, so Crispian asked, let's see if the TTS works. Here it goes.
Outside the box said, size of bed again.
The size on that H2D, from memory, it's 350 by 320 by 325 is the build volume, something like that. Yeah. Tassie Bob says, Emily the engineer made a life-size Benchy that floated. Yeah. What's the name of that guy? There was a guy who used to print everything in red. That was like his trademark. And I can't remember, his name. I used to watch his videos quite regularly. He 3D printed it. Ivan Miranda, that's it. Sion, welcome. And Austin came up with the same answer. Ivan Miranda, right. Yeah, he has built multiple enormous 3D printers, very high flow things, and ended up 3D printing a tank that he could sit in and drive around. And he also made his own CNC machine and all sorts of things. So really cool project. If you haven't heard of Ivan Miranda, go and look up his YouTube channel, check it out. Cool stuff. Crispian says, stability was an issue with the life-size Benchy. Yeah, I am not in the slightest bit surprised. So, that is the summary of the keyboard status. The Softplay Choc keyboard, the more I use it, the more I like it. Even from the start, it felt good, but now it's becoming much more natural, to the extent that now when I jump on a laptop or some other keyboard, it just suddenly feels wrong. I am acclimatizing to the soft late shock. So, okay, now the actual point of all of this, the point, PC, I'm going to open Conveyor. Conveyor. Now, okay, I'm going to need to give a little explanation of what I'm trying to do here. Oh, and the other thing I've been 3D printing is frame parts for the conveyor, which come out brilliantly on the bamboo printers. So yes, this is the integrated frame with the, this is one of the corner pieces for the frame, a little hard to see. It's got the PCB sensor mount there rebaited into it. It's got the holes for the extrusion to plug in. There's a mount on the top for the top rail to clip on. There's this, there's the screw for the, that comes up from underneath, and on the bottom there is a large clearance hole there to get a, like the head of the bolt through with a socket, like a hex driver.
Austin's_creations said, does this mean you have new displays in hand yet?
No, it doesn't. Okay, so let's state the problem so we are all clear on what I'm trying to do here. And this is where Austin is probably going to get angry at me for not doing this the right way, but I'm doing this as an intermediate step. So I ordered the displays, the plus versions of the displays, so that I could begin the conversion. What we're looking at here is the board that works with the WT32 SC01, I think. Is my memory correct? I don't know. And yeah, main board header. So there is no microcontroller on this board. This is all I/O, and it plugs into the touchscreen board, the display module, which has a header on the bottom, and well, it's got a header on the bottom and a header on the side, but it's the same thing, just duplicated. And so what I'm doing here is connecting into the I/O from the ESP32 that is on the main display board. Oh, which reminds me, for those of you who haven't seen, yes, I have a squixel right here. Just got to wake it up. It is loading its, hang on, I've got to, this is another one of Sihon's projects. So cool. Kind of relevant to this whole discussion as well. So go and check out Unexpected Maker. This is, can you read that? It is a squixel, which is a touchscreen ESP32 based device. It's got magnetic connections on the back for USB and charging, and comes with the dock, which is currently, I won't move it up into the field of view. It's currently stuck down. So the idea is that it runs off battery. As you can see, it's running right now off battery, and it's touchscreen. But you can also just snap it into the dock, and then you get USB and charging. So yeah, super cool. Yeah, the effort that Sihon has put into designing that is pretty epic, and the result is really, really nice. So seeing that has been a little bit of inspiration for this whole thing as well, and made me think that what I need to do is an intermediate version of this design which does not have a touchscreen on it, because what I can do is use something like a squixel as the controller for, like, as the user interface. So, okay, I'll back up. Let's state the problem again. Now, I have the WT32 SC01 touchscreens. I've got like 5 of them or something, and that's what I was intending to use for my PCB controller, PCB conveyor controller. with this as the I/O board stuck on the back of it. And that is exactly what my prototype conveyor has on it right now. The thing is, that particular module, that touchscreen board, module, display, whatever you want to call it, has some issues. It is a little unstable. It crashes after a while. Now, I found that I could actually improve that significantly by adding decoupling. I loaded a bunch of extra capacitors onto my add-on board on the power rails of the touchscreen board, because it would crash quite frequently. And I think on that design, they just haven't done a good enough job of the power supply side of things. So adding...
Unexpected Maker said, that's what I have for my conveyor controllers on my line. All controllers are screenless with Matt, and I have SQUIXL for control.
Yeah, nice. My guess is that was an autocorrect, and when you say screenless with Matt, it would have been screenless with MQTT with a squeaksel for control. Right. Very good. So it seems that I am thinking along the right lines then. Yes, Sion, Matt is equal to MQTT. That's exactly the plan that I have for this. So this is an I/O add-on that does not have a microcontroller on it. It relies on the touchscreen that it plugs into to be which has the ESP32 and the touchscreen on it. But that particular touchscreen it's a real pain in the ass to work with using LVGL and the drivers and things. It's just, yeah. It's been beyond my ability to make it do useful things very well. So Austin has been using the updated version of that, so the plus version of that touchscreen module, and reports much better success. So if I'm going to put a touchscreen on it, what I would want to do is switch to the plus version of the touchscreen module. However, that means I need some. I ordered some. Delivery failed. The delivery driver got to my door and decided that he couldn't deliver them, and then took them away again. And then I got a notification saying delivery failed, and I contacted the delivery company, which is iMile, and they said, sorry, the return process has been initiated. They're heading back to China. Nothing you can do about it. So they failed to deliver, and then they sent them straight back to China. I ended up getting a refund from AliExpress, so at least I'm not out of pocket for it. But the problem is, I don't have the modules. So this is decision point time. Here we go. My plan. Austin said that in order to use the plus version of the displays, what he does is make his own replacement board that goes on the back of it with the ESP32 on it. And then you have full control over what it needs to do, like all of its integrated I/O, etc. So I've been thinking that what I would do is take this and some other suitable project, and the most suitable, I believe, is OpenKO 1.1. Let's open this one up. Okay, so what I've got here are two projects that each have part of the solution. I'll just go back. I'm going to get the folder structure all set up, and then I will close this so that we've got more room to work. Where are we? PCB conveyor. Or is it just conveyor? In some places I call it conveyor, in some places I call it PCB conveyor. Very confusing. All right, so I'm going to do new folder and call it oh, my keyboard isn't plugged in. No wonder it's not working. Yeah, I can actually make this keyboard wireless, but conveyor V10, no, What am I doing? Not 1 0, 3 0. So I can make this this keyboard wireless if I switch the microcontrollers note. But anyway, let's not get into that particular squirrel again. All right, now I'm going to go into this folder and then close the tab so that we can do what we need to do. Get rid of that. Don't save. I'm going to get rid of that. So what I have now with the existing Conveyor project is all of the I/O that I need. I've got the x-axis stepper interface. This goes out to an external stepper driver board. Oh, sorry, I said X. The y-axis stepper interface. Then the x-axis motor driver, which is just a little H-bridge. It's a DRV8871 or 8872. Either of them will work. Which is driving the DC motors for the front and back rail. So that's for the actual conveyor belt. I still go backwards and forwards on replacing the conveyor motors with steppers as well, but at the moment I'm sticking with DC motors. We've got the y-axis limit sensor, we've got the I/O expander, which provides us with a whole bunch of extra things because the I/O is very limited on that display module. Then we have ready in and out connections on the left of the board. So we've got an opto-isolated input and we have a read relay switched dry contact output and duplicated on both sides of the board. So the idea is that the controller is kind of generic. It can deal with either the left side of the board the same way. So you can make a left to right conveyor or a right to left conveyor. It doesn't matter. We've got provision for it all in the control system. And these are linked to the I/O expander. Then we also have a CAN bus interface. So we've got a TCAN 332 on there, which I might replace with a fully isolated CAN transceiver. I would be very tempted to do that in a redesign because I use fully isolated transceivers now on all of the water truck projects. Then we've got the PCB sensors. So these are the 3 time of flight sensors with their activation, like enable X-shut lines going to each one so that we can start them up and give them unique I2C addresses. There's a regulator module. So this is just an off-the-shelf 5-volt regulator module plonked down on the board and a power switch. So that is the I/O and power that is required. Oh, Scott says, what about up-down conveyor? A really short space elevator. Ah, great. So yeah, the I/O functionality is contained within the Conveyor project. Then over here we have the OpenKO project, which has among other things, well, that's weird. The first page is the USB hub. So this is the USB hub thing, the project that we worked on a little while ago. We've got the upstream USB port. Oops. And then downstream, we have the connection to the actual protocol converter, which is going to the ESP32. And we've got a couple of pass-through USB hub ports there for connections to cameras or feeder controllers or whatever you want to use. We've got the microcontroller ESP32 Vroom 32 S3 module, so that's an ESP32 S3, and we've got CAN bus connections on there, piezo, other things, I2C, yeah, that's the eye of Steve, the LED. CAN bus interface there, KO interface, so we've got KO serial, the little 128 by 32 display, quick connector, status LED for a stack light. What's the other thing? Oh, and just power. Okay, so this is just the all the voltage regulation stuff. So between the two of those projects, between the OpenKO project, which provides the microcontroller and basic stuff, and the conveyor, which has all of the specific I/O, if we munge those two things together, we end up with the functionality required.
Technebulous said, at Technebulous.
Okay, where was Technebulous's comment? I might have a solution for you on LCD. Check your Discord, private message, Technebulous. Aha, okay. Let's see, I'm just going to pull up Discord. Let's see where I don't see. Maybe it hasn't come through yet. I don't see anything recent. Yep, hang on, I'm just going to send a message. I'm just replying to Tom, who sent me a message. Yeah, sorry, Technebulous. I do not see a DM unless it's like in PCB conveyor. No, I don't see where it is. Maverick. Yeah, I don't see your DM. That's weird. Is it a DM or was it a... Oh, okay. Anyway, I will check that out later. So, here is the plan. What I want to do is merge the Conveyor project and the OpenKO project to make a Conveyor controller which will have the microcontroller, so it'll have the ESP32S3 and all of the Conveyor peripherals integrated into a single project. That will not have an LCD on it. It'll just be a self-contained controller. At the moment, with the firmware that I'm running, what I'm doing is controlling it using Node-RED. So let's let's see if I can find. I want to find, where is it? 1885. Dashboard, page 1. Is this going to be the right one? Conveyors. Yeah, so at the moment, this is what I use. So this is just a Node-RED interface. When I click on buttons in here in Node-RED, it publishes to MQTT, and then that is picked up by the Conveyor controller, which responds. So if I want to home the Conveyor, for example, I just click the home button. That then publishes that to MQTT. It does a G28, which is a home command, and the Conveyor homes. So I can set the width of the Conveyor. If I wanted to have like a 120 millimeter PCB pass down it, I would just go width 120, set width, and the Conveyor moves to 120. I can stop it manually. This button up the top sends M57 S700 P180. So what that means, I could have made this a human readable label, but I'm still messing around with this. M57 means dispense boards periodically. S700 means run at 700 millimeters per minute, so that's speed 700. And P180, so pause 180 seconds between boards. So if I click this button, what happens is that the Conveyor will dispense one board every 3 minutes, and then until I click stop. So it'll go eject a board, bring the next one to the exit sensor, and then stop for 3 minutes, and then send that one out, and then bring the next one to the exit sensor and stop for 3 minutes. So this is for feeding boards into the reflow oven. That is the actual specific use case for this. and because the oven has approximately a 6-minute transit time through it from beginning to end. So this is Sion's former reflow oven, the Neoden reflow oven. It's about 6 minutes end to end. So by feeding a board in every 3 minutes, it means that it's basically half-length gap between the boards on the conveyor through the oven. So that means that it has plenty of time to maintain its temperature and not have problems with energy being absorbed into the panels. So now my point is, right now I can control the conveyor using this Node-RED interface, which just publishes to MQTT. I could do the same thing out of Sion's Squixel and have this as the interface. So what I could do is have a Squixel in the dock down near the conveyors, or in the production line area, and I could just pick it up, walk around, and have this as a control panel and tap things on it, and which publishes to MQTT, and then the conveyors can be controlled through this. So the whole idea of that is opened up possibilities. It reduces my reliance on something like a touch screen on each of the conveyors, because they can all just be controlled through a portable handheld touchscreen that doesn't have to be physically attached to them. Sion said, check Discord DM from me. Okay, hang on. Where? I've got a DM, DWIN displays. I have Xstock. Ooh, okay. So Sion has just forwarded me some things about displays. And yeah, cool. Okay, from Technebulous. Okay, so so that was Technebulous's message. All right, thank you very much. I will follow that up. Now, by doing this, by merging these two projects, what it does is it gets me to an intermediate point where I have a self-contained controller that has the onboard microcontroller, and it has all of the I/O, and in future I could convert this into a format where it integrates with the Plus touchscreen, which Austin uses. But in the short term, before getting to that point, I can use it standalone with no touchscreen, and I can control it from a Squixel or from my phone. So literally, I've been using my phone to control this. Like I'll just walk at the production line with my phone, pull up the Node-RED interface. I pull this up on my phone and control it that way. So it removes the reliance on having it as a touchscreen. Tassie Bob says, Squixel inbound for tinkering. Thanks, Sion, and thanks, John, for the heads up. Nice one, Tassie. Yeah, it's a very cool little device. When you get it, you will be impressed not just by the device itself, but by the care that Sion has put into the packaging and presentation. It's really nice. Yeah, you open it up, everything is perfectly packed into laser cut foam, and it's got the branding on the foam. Nice job. And Tassie says, Reflow Master Pro will be baking some boards this afternoon too, Sion. Yeah, so here is, let me just start doing this. It's one of those things where I should just start doing it, because it's going to be faster than trying to explain it. No, not 3. All right, I'm going to pull in the schematic from 2, and I'll also reference the board from 2, and then I'll explain a little bit of what I'm doing when it comes time to merging the projects. So what I'm doing right now is just the usual stuff you would do if you wanted to create a new electronics project in Fusion and reference an existing project. So if I now save this, and I'm going to save it as Conveyor version 3, it's actually just an exact duplicate of version 2. So version 2.0. So we now have a project which is Conveyor 3, version 3, and it has the schematic and the PCB from the version 2 Conveyor. In fact, I'm going to close the Conveyor version 2 project just to get it out of the way. Alright, so this is a situation where you would have, say you've got one project in Fusion and you want to merge another project into it. We want to make a project which encompasses both the PCBs and the schematics, and ideally, so this is something that Fusion does really nicely that was always a pain in Eagle. You could kind of do it in Eagle using submodules and things. I don't know how KiCad handles this. I have no idea. It possibly handles it really nicely, I just don't know. That would be an interesting thing to know about. So, okay, what I'm going to do here is start from Conveyor version 3.0, which is going to be the project that I will merge everything into. And now I've got to, it's a while since I've done this, so I've got to figure out where do I do it. Edit, view, I can't remember if I do it from the schematic or from the project. Maybe from the project. File. I should have refreshed my memory about this before starting the stream, shouldn't I? Can I do it from here? Edit, view, edit. Where do I do it from? Document. I'm probably going to have to look up the documentation for this. There is an option in here. Someone will be... Oh, here we go. Here we go. Okay, this is it. So what we've got is the electronics project, which is a direct copy. Then we go into the schematic and under place. So normally if you were wanting to, say you're in a project and you want to add a new component to it, the usual thing you'd do is use the place options. So you can do place components, you can do insert schematic, insert design block. So a design block is when you have a pre-saved subsystem. Maybe you've got a power supply or something like that that you regularly use on multiple projects. You can insert a design block. But in this particular case, it is we want to, so you can insert a schematic, or you can do DXFs and SVGs and all those sorts of things as well, which is pretty handy now. It'd be nice if you could just insert like a JPEG. That's something that that Autodesk definitely need to add, which I think KiCad does really nicely. Like you can add things like screenshots of data sheets or connector pinouts or whatever, insert them into the schematic in KiCad, and it handles it really nicely. So what we're going to do is insert electronic design, and what you do is you find where that design is. So I'm going to go into projects and OpenKO and OpenKO 1.1, and I'm going to grab the schematic from the OpenKO project and hit select. Do I want to overwrite? No. Yeah. Net names, okay. And this will replace the net names. Library update failed. Oh, okay, that's because I'm not fully up to date on this project first. So if I go to library update, oh, that has changed. Okay, apply that. And you can see that it's screwed up this connector because it's been a while since I've done this, let's go to bend. No, don't retain. Move and move it up to there. Okay, that should be a little bit better. Let's do a quick eyeball of the other parts of the schematic. Oh, that's screwed up as well. Why is that over there linked to that? Yeah, this is this is really screwed up because of the oops. Oh, come on, because of the library changes. That goes to there, and can I do that, or is it gonna, oh come on, no, it's going to insist on rubber banding in a way that I don't want. So let's just fix up all this ugliness. Yep, so the loop removal did its thing there at least. And then we'll take that to there, up there and there, which also did a loop removal, and to there. Okay. So I'm probably going to replace that CAN transceiver anyway, but yeah. Okay, so now we are in a state where hopefully we will be able to merge the other project. I wonder if I need to do a library update on the other project first. That might be an issue. Okay, let's try this. I'm going to come into OpenKO and do a library update on here, just to make sure both library updates failed. Shield in the old version of symbol USB 4P can't be mapped to any pin on the new. Okay, so it's having trouble with the USB connector because I've changed that. Where was it? Which USB connector? That one? Yeah, it's had trouble with that. Well, this is kind of an ugly process because I've been updating my libraries a fair bit since working on this, so various things are failing. So I think that this is probably going to fail if I try to do this insert again, but let's try it anyway. Place, insert, electronic design, and I'm going to go back to, where are we? Superhouse projects. Come on, Superhouse projects. Oh, Rack 32. No, it wasn't Rack 32. It was OpenKO. Wrong one. This is probably going to overwrite. In this case, I'm going to say yes. Yes. Oh, it did work. Okay, cool. So the fact that the libraries needed to be updated in the source project didn't matter. Okay, so what you can see along the bottom here is our, we've just gained some extra sheets in our schematic, because what it's done is we've got the original project schematic here, and then it has imported the OpenKO parts of the schematic all onto their own sheets. So we now have all of the parts from both projects combined. But if we go into the, okay, so now what happens with the PCB? And now if we go across to the PCB tab, I'll click into that, you can see that what it's done is it's placed the extra PCB down below it. So we now have, I'm going to run polygon pour and then rip up. So we now have two PCBs in the same project. What's my grid there? 0.5, that'll do. Okay. So I'm going to move that group. We've got the two parts of the PCB. So merging projects like this is never going to be super smooth. It's always going to be kind of annoying. But the advantage of doing it this way, so the way it used to happen in Eagle was if you brought across part of a schematic, say a schematic from one project into another, it would bring all the parts over as well, but they would lose all of their geometry. With the insert electronic project in Fusion, what it does is it brings over the complete PCB from the other project and pulls it in. So we now have two PCBs in the same project, which is not ultimately what you want, of course. You want all of this merged onto a single PCB. But the nice thing is that this has now retained all of the geometry of the project that was imported. And you can then edit the board outline and create a single board, delete tracks that you don't want, and merge all of this together. So I'm just going to save it as it is right now with the two PCBs unmerged. Yeah, so the next step is, and now I can close OpenKO. I don't need that open because we now have the project doing save. So I've now got the Conveyor 3.0 project, which has been merged. It's got the two PCBs in the same project. It's got all of the schematic in the same project. So now what I can do is go through and have a look at this and figure out which things I care about keeping and which I do not. So if I come to this, and there's some double ups. Right now we have this CAN bus interface on the Conveyor board as part of the original Conveyor project. And we also have a CAN bus interface on the OpenKO board. So what I'm going to do, I think, and then I've got to decide which one I want to keep and which one I don't. Now, because for pin mapping reasons, I think what I'm going to do is keep the interface that is on the OpenKO portion of the schematic, because it already has I/O linked here through to the S3. And also I don't know if I need a USB hub. I don't think I do need a USB hub. So what I can do, what have we got here? 48, is there anything else on this? We've got the USB port upstream. We've got, we are definitely going to need a USB connection because we need to be able to load code onto the S3, but we don't need a hub. I'm wondering if there's anything on this sheet that is worth saving. We've got the downstream ports, we've got the connection that goes to the S3, we've got the upstream USB-C connection. I think I'm just going to re-add anything that I need from there. So what I can do is remove the entire schematic. So that entire sheet of the schematic is now gone. And if I go back into Conveyor, you'll see that there is a chunk of stuff that's now missing on the PCB. So this is where the USB connection used to be. I'll just do a bit of cleanup there, get rid of some tracks. There's going to be a lot of ripping up here. You can see the USB connections over here are gone. There are some stub tracks here that are no longer doing anything useful. Get rid of those. So now the process is just kind of repeating this a couple of times. So we've got the CAN bus interface here. This is the original one, which is on the Conveyor controller board, and I don't really know what to do about the connections. I think I definitely want to keep two CAN bus connectors because we need to be able to daisy chain these conveyors together, have them all on the same CAN bus. So I think what I'm going to do is a selective delete. Now, what do I need from this regulator
Unexpected
section?
Maker said, if only you could just add an M2 connector to your existing board and plug in an ESP32S3 to it.
Ah, with a little winky. I wonder who is working on a board that does that. Or has a board that does that. Wouldn't be anybody in the chat by any chance. So we've got V in raw here. We've got the switch mode regulator. 3.3 volt regulator there. Okay, I'm going to leave all of that for now. Do I have any power supply? Oh yes, I do have power supply stuff hanging around like a bad smell from the conveyor controller. So let's get rid of this. This is the off-the-shelf 5 volt regulator. I'm just going to go kaboom, you are gone. So PCB sensors, all of that stuff is going to stay. KO interface, that goes. So let's have a look at deleting stuff from here. I'm going to delete the KO serial interface. Part of this is going to be deleted, but not yet. Oh, it's got a MOV on there. That's interesting. That must have been part of my noise suppression strategy. Status LED, stack light. Yeah, that can probably stay. Piezo. We've got a quick connector here. I feel like deleting that just to make Austin scream. Yeah, okay. So, now to rationalize the CAN bus interface, what I'm going to do is come over here, do a group. Oops, not that. I've got to select that and move that group onto the other sheet and stick it here, because what that lets me do is see both parts of the CAN bus interface together and then selectively delete. So I want to keep 2 connectors. Is this a vertical or a horizontal connector? Screw terminal, plug horizontal. Okay, they're all horizontal. These ones I think are horizontal as well. Or maybe these are vertical. They actually fit on the same footprint. Oh yeah, these ones are set as vertical, which I think is what I want. So where are we? IO16 CAN TX, IO5. I think maybe my simplest approach here is to just duplicate the pin allocations. So I'm going to bring these along a little bit and rename that. So TXD is going to be, yeah, let's do all segments on all sheets. IO16, IO16 CAN TX, yes, yes. And then I'm going to change this one to, where are we? IO17, IO17 CAN RX, yes. Okay, so that little, that can move to the VREF pin, 3.3 volts. Yeah, I could do with a bit of cleanup on the schematic here. Okay, so we've got VN coming in through an SS56, so it can be powered via the CAN bus connector. There's a MOV on it. Do I care about the MOV? I don't think I do. So I think at this point what I can do is just nuke all of that. Okay, so now I've got the CAN bus interface here. What I'm debating is replacing this TCAN 332 with something like an ISO 1042, and okay, the reason is the ISO 1042. Okay, I think I've just made my decision in my head, but I will explain my decision. The TCAN 332 is a CAN transceiver that runs off a 3.3 volt supply, and it works with 3.3 volt logic. And that means that it has like a little internal charge pump, because CAN bus logic runs at 5 volts with a 2.5 volt midpoint. It's a differential signal that when it is in recessive mode, the two lines are at 2.5 volts. And then when it drives data through it, it drives CAN high up and it drives CAN low down. So the signals are normally the same, and then they go ba-dunk, and then like that, ba-dunk. Well, no, always CAN low goes low, CAN high goes high, and they go into a resting state at 2.5 volts nominal. Problem is that with 3.3 volt logic, you can't drive CAN high. Oops. You can't drive CAN high up to 5 volts. So it works, but it's not ideal, and it's also not fully isolated. So let's try, where are we? ICs, Superhouse ICs. I've got to find the thing, ISO 1042Q1. Okay, this will do. So this is a fully isolated CAN transceiver with dual power rails. And I've used this with great success in a variety of projects, and I very much like it. The reason that I hesitate, so, okay, this part, the ISO 1042Q1, is a dramatically superior part compared to the TCAN 332DR, which is the one that I used for many, many years. The thing is, I have hundreds of these, and I kind of want to use them up, but it feels like the wrong thing to do to keep it on the board when I could be using a better part. So the fully isolated part has a number of nice characteristics. So here's what I'm going to do. I am going to, well, firstly I'm going to delete that note because it's not going to be relevant anymore. I am going to delete the 3.3 volt CAN transceiver. I no longer need this bias resistor, and I no longer need that, and I'm going to move a couple of these things out of the way. Now the thing is that this isolated transceiver is physically bigger. It is a wide, I can't remember what the package is called. Maybe if I look at it, look at this, it'll tell me. SO8. Yeah, so it's a SOIC, but it's a SOIC W. It's a wide SOIC chip because internally it's got, I think it's 1,000 volts of isolation between the two halves of the chip. So a regular SOIC package is like, it's like a dip. It's 2 rows of 4 pins. It's a total of 8 pins. And you can see here on the schematic the pin numbers on this. So we've got pins 1, 2, 3, 4, which is one side of the chip, and then 5, 6, 7, 8, which is the other side of the chip. Internally, this is a fully isolated CAN transceiver. So it's got 2 power pins, it's got 2 ground pins, 2 TX pins, like TX and RX on one side, CAN high, CAN low on the other side, and it has full galvanic isolation. So the which one is which? That is CAN low. Yes, that's right. Okay. So what I can do is connect it on one side. I'm going to connect, I'm going to stick a ground down here. And so on this left side of the chip, we have a 3.3 volt supply. Oh, and the other nice thing about this, okay, let's see if I can find a, is there one on this part of the schematic? I suspect there is. Oh, there is one. Okay, so we've got a 5 volt symbol here. All right, so what we can do is we have a 5 volt supply on one side of the chip. Let's neaten this schematic up a little bit. I'll bring that over there and copy that and put another ground down here. So the left half of the chip, it's really 2 ICs in a single enclosure, almost, is one way of thinking about it. So on the left side, we've got the 3.3 volt half. It's got a 3.3 volt power supply off a ground reference here, which is the same as the ground on the rest of the project, including the microcontroller. That's the critical thing. That ground has to match the microcontroller ground because that is the voltage reference for these I/O pins. Now this transceiver can run on 5 volts both sides. So what you could do is if you were running this with a 5 volt microcontroller, what you do is you put a 5 volt supply on here and then all of your I/O runs at 5 volts. But I'm connecting it to an ESP32, so I'm putting a 3.3 volt supply, which means all of the I/O is going to be at 3.3 volts. So that left half of the chip right there is in 3.3 volt land. And then the right half of the chip is being supplied at 5 volts and has CAN high and CAN low coming out of it, and it has its ground reference. So this half of the chip is in 5 volt land, and it will be able to drive full voltage excursion, like full range voltage on CAN high in particular, on the CAN side of things. Yeah, this schematic is a bit messy. It needs cleaning up. It was munged into that shape to make it fit within the sheet, but it's not ideal. I should bring this further up and around. I'll do some cleanups on the schematic. And yeah, there's the CAN protection, like TVS, transient voltage suppressor. So there's a dual transient voltage suppressor in one package. We've got power from the CAN bus coming in through a diode to V in, and then somewhere there is a power switch. Maybe on this schematic? Yeah, V in. So V in comes to the power switch, which then goes out V switched. So we can power this from the CAN bus connector. I'm going to move, just for the sake of getting things into the right place. I haven't yet deleted this little I2C display, and I'm in two minds about keeping it. I just don't know whether to keep that or not, but I am deferring that decision. I'm ignoring it for now. Doesn't quite fit. That's annoying. Oh, that can all move to the right anyway. Okay, so I can make space. So I can go and move that to the right. Move group, yep. Stick that across there somewhere, and then grab that and move that over to there. Right, so we've got all of that on that sheet. And now, because of the update, it's moved those do not connect symbols off the pins, because those symbols got changed in that library update. Okay, I'd better save just in case Fusion freaks out, which it still does regularly. So what have we got on the PCBs? All right, so there's a whole lot of stuff now that's been deleted off the OpenKO portion of the PCB, and that's freed up a fair bit of space. There's a little bit that's been deleted off there. What is down there? Oh, that is the isolated CAN transceiver. So I'm just going to stick it there for now. Okay, so what I should do is show you the process for merging the PCB outlines. But I don't know. Will I do that or that? Okay. I'm going to do an ugly job of it. Ooh, okay, here's an interesting thing. Check this out. When the... Oh, there are some things to delete as well. There are some keep outs that are hanging around because they were from the fiducials that I deleted, because I deleted a sheet. So the, oh yeah, we can get rid of all of that. And I'll get rid of that because it's going to be on here. Now, when I brought in the PCB from the second project and it got dumped in alongside the first thing, it put it off the grid, and we now have to fix that. So what happens is, say we look at any of these parts. I'm just going to look at this piezo. You look at the positions, 141.06 blah 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 millimeters by 29.515 blah. It's on some stupid position, because what it does is looks at the external dimensions, and in this case it would have been like a reference off this this fuse holder. So the fuse holder here ends up off grid, and various other things are off grid as well. So what it did was it plonked it down clear of the original board with a margin, and that means that it is off grid. So if we now try to merge these two boards, we will have parts from the original one which are on grid. Like if I look at this resistor, for example, it's at 73 by 42 millimeters. All of the parts over here are at totally bogus. Oh, that one's not too bad. 119 by 16.3. And what's this one? 157 by 7.3. Okay, that's actually not too bad. There's something weird has gone on with that other thing that I measured. Where was it? The piezo. Okay, so the piezo is in a bit of a strange thing. So it has put them, the X grid is fine. It is at 125 millimeters for that. So we don't need to correct the X positions, but the Y positions are off by 0.3 of a millimeter. And there is an easy way to fix that. So the way I do that is, whatever the amount is that it's off, I change it to be that amount plus some large amount. So say, let's make the grid 10.3, okay? Now the amount that these were all offset was 0.3. Now it could have been, say your grid offset, the position that was wrong was 0.0427, like some strange number like that. What you do is, the temptation is to set the grid size to that amount and then try to move everything onto the grid. That can work, but you've got to be super, super careful. So this is the trick. What you do is you take the amount that you want to offset it, in this case it's 0.3 of a millimeter, and then you add some larger amount to it that is a round number. So I've just made it 10 millimeters. So now we've got 10.3 as our grid size. So I'm going to hit OK on that, and now we've got a nice big fat grid. And what that means is that if I select all of this, and then I do a group move, and I move it one grid snap down, so I'm going to go snap, there we go, one grid position, and then I'm just going to switch back to a regular 1 millimeter grid. What we should find now is that it's moved everything 10.3 millimeters down, which has removed the 0.3 offset, the positive offset. So if I now have a look at the position of this diode, for example, it's at 119 by 6 millimeters. It's perfect. It's spot on the grid. So all of the, apart from that piezo, which seems to be, I don't know what's going on with that. So this is now at 125.5 by 26.5, because that would have been put on a half grid position just for spacing reasons. But you should see now that these parts are now on the grid as far as the original project is concerned. So now what we can do is merge them much more easily. So I've gone back to a 1 millimeter grid, and I can move this around in nice snap increments of 1 millimeter. Now this particular part is off grid because we ordered it, or because I placed it when we were offset. So I'm going to change that back onto grid. So that's now on the 1 millimeter grid. But that now puts us in a position where we're in a much better state to be able to start merging these particular boards. So if I do a polygon pour here, you can see that it's still effectively 2 boards because it's got the cut lines, the outlines of the 2 original PCBs. So what I'm going to do is rip up those pours, and I am going to delete, what did I just do? I just deleted the wrong thing. So what I'm going to do is go to dimension layer and single layer mode. So now all other layers are locked out. I'm only looking at the dimension layers. You can see just the milling lines that go around there. And then I am going to delete some parts here and just merge these 2 things together. So get rid of those curves there. And is that on a grid? It looks like there is 5801. All right, let's make that. In fact, what I could do is, there's probably the simple way to do this is delete all of the outlines and just draw a new board outline around the whole friggin' thing, and then start moving stuff together. So I'm going to get rid of, but what I'm going to do is I'm deliberately going to leave this part of the board to keep that little bit of geometry, just as a way of demonstrating merging the 2 boards. So I'm going to get rid of that, and now, oh, and you can see the actually the thickness of that line is different. That's interesting. So this one was set to be width 0. This will be 0.15 or something. Yeah, 0.1524 millimeters. So let's do a line. Where are we? Document. Sorry, got to go into the right ribbon. 0.1525. That'll do. I'm going to snap onto the end of that, and I want a curve. Yeah, I want a curved end. So how far in do I want it to be? Maybe 4 millimeters. That's 4 millimeter radius. That'll do. And then bring that down to join to that. And I need to change the width of those lines as well. But if I now join that to there, has that done it? Let's see. Back to design. We'll run the polygon pause, and it's within that zone because the actual ground polygons now are still bounded by that. So what I can do for that is I'm going to go into this layer and get rid of, if I can, where's delete? Delete this polygon. Yes. Okay. Come on. Where are the edges? Oh, it's got little segments. At some point this polygon has been, yeah, I don't know how it ended up like that. It got converted into short line segments, maybe through like an import process or something. So I'm going to, I know time is getting on, so I'm not going to, that's why I'm having to delete so many little segments. Delete, and then that polygon should be, is it totally gone? I think it is, yes. So that polygon is now totally gone. So if I'm going to get rid of these curved segments as well, because what I want to do is just make this polygon a simple rectangle. In fact, I'm kind of tempted to delete the whole thing and then just do a new polygon, but I won't. I'm going to, or will I? Or will I? I think I'll just munge this existing polygon and make it encompass the whole thing. So bring that to there, and what can I do with that bit? Bring that one up. Oh, there's still a little segment just there. One of the little
Outside
segments.
the box said, Jono, you need the FAF automation protocol.
A what automation protocol? A DFAF automation protocol. Okay. I'll get rid of the angle constraints. DFAF. Yeah, I need DFAFing. All right, so turn angle constraints back on. Ooh, okay. I've got this weird little offcut in here, so I'm going to get rid of that and that and that, which should make it straighter. Oh, and this, yeah, I've got to get rid of all the little segments here. So much of this is just faffing around because of artifacts that were in the design originally. Okay, remove angle constraint, bring this back to here, make it vertical approximately. Okay, angle constraint, can I move that? Yeah, I would be better off just drawing a new polygon, but I am stubbornly trying to make this one approximately fit. So anyway, now, okay, there we go. So now that polygon encompasses both the boards. And that is, yeah, I will draw a new polygon. And I need to clean up, you can see the edges of the other layer polygons there. So I will need to clean up. So the next step in this process, let's do a save, is to continue going through the schematic and rationalizing the connections. On the first sheet right here, we have the I/O header that goes to, that went previously to the touchscreen board. We don't need that anymore, but the pins that are on here are useful as references, the nets that are useful. So my normal approach in this sort of thing is to delete the connector, leave all the nets, and then remove all the superfluous stuff. For example, the ground things, we don't need to be reminded of those because we've got grounds elsewhere. We don't need to be reminded of the power rails, so let's get rid of all of those and have it leave us with just the signals that we care about. That one, is that it? Yeah. So remove the 5 volts, remove the 3.3 volts, the ground. There we go. This will simplify it a lot. Now these particular nets we weren't even using because it's got the little do not connect symbols, or the not connected symbols on there. So I'm going to get rid of all of those nets, because what this is effectively doing is giving me a to-do list. And that one, get rid of that. Okay, so what we have is a to-do list of the various nets that we now need to route to the new microcontroller, because they were previously going through the header to the touchscreen board, which had the ESP32 on it. And that's now gone. So these nets have to be taken care of somewhere else, like IO35, Y limit, and in2, in4 on the stepper motor controller, etc. Well, the CAN doesn't matter anymore because we've now linked that. So this is an example of something that we've solved. So the CAN TX doesn't need to be there anymore, and CAN RX doesn't need to be there anymore. So now we've got ESP-EN, so that's the enable pin. That'll be taken care of elsewhere, so we can get rid of that. You can see that it's up here already on the I/O expander, and that needs to be, that needs to be linked on the other thing. So then we have limit, we've got the stepper motor controllers, we've got I2C. So we've got SEL and SDA on there. So we'll get rid of those, which leaves us with these pins that have to be allocated on the new microcontroller. So what I'll do then is take these and I'm going to move these to the sheet where the microcontroller is and stick them here so that they are visible. So what I can do is have a visual reference, figure out what pins I now want to assign each of these to, and link the nets on here. Let's see, IO35. Where is IO35? There, okay. So what I could do, for example, is make IO35 Y limit. I kind of want to avoid that because that's the copy pin or MOSI, and that way if I need to use SPI for the display, which I probably will, I don't want to have that in use. So, Stephen says, I find it simpler to route the trace next to the ESP32 and then assign the pin on the ESP. That avoids unnecessary jumps up and down to route around traces that could otherwise just go direct. Ah, okay, yeah, that is a good tip. So what Stephen is talking about there is a lot of I/O pins on the ESP32 go through the I/O matrix, which means that you can assign them to any particular purpose you like. I2C, for example, doesn't have to be on pins 4 and 5. It could be anywhere because the internal I/O matrix allows you to map them. So rather than have 4 and 5 predefined, like SEL and SDA being predefined as going to I/O 4 and 5, what Stephen's suggestion would be is to leave them unconnected here on the ESP, unassigned, and then on the PCB you route them to near the ESP, and then you just see which pins they happen to fall out to be near. So in this case we've got the TX and RX pins going to the CAN transceiver, and they could be on different pins. We could reallocate those if we wanted to. So what you would do is route the tracks from the CAN transceiver to near the ESP, and then you see which pins they are close to, and then you simply assign those in the schematic. And that way you end up with the easiest possible routing job. Tabraze says it's 3:22 a.m. time for bed. Yes, go to bed, Tabraze. That is kind of crazy. And also, don't go blowing yourself up anymore. Try to avoid any more trips to the hospital, okay? Don't do that. Yeah, so that is a good tip from Stephen. But I'm not going to go on any further with this today because it is, well, as Tabraze said, well, for Tabraze it's 3:22 a.m. For me it's 12:20 something, just after lunch. Well, it's about lunchtime. So we should all stop and either get lunch or go to bed, depending on whether you're in Estonia or Australia. So yeah, at this point, we have a project which has, maybe not, but probably everything we need on the schematic. It's not necessarily totally neat on the schematic yet. I still need to finish I/O assignments and cleaning things up, consolidating things, because we've got a lot of half-empty sheets here. But with a bit of cleanup on the schematic, we can then...
Tabraze no go boom. Henry go boom.
Tech Nebula says, just check the DWIN reference I send as the interface required only serial or CAN bus. Okay. So I will check that. Yeah, that's the display that is being suggested. So at the moment, I am not committing to a particular display. My goal here is to build a control board without a display that I can control from my phone or from the OpenPNP interface, because I've got it set up so I can send CAN messages from OpenPNP by clicking buttons in the UI, or from a Squixel or whatever other touchscreen solution there is. And then I can add a direct touchscreen display in the future. I've got the potential for doing that, but I just need to make it so that it functions now, and then the touchscreen can come later as an optional extra. So yeah, my next step is going to be cleaning up the schematic and making sure all of the I/O pins are assigned correctly, and then in the PCB layout, there'll end up being a whole lot of stub wires and things that just need to be deleted, and then I can do the arrangement and merge everything together into a single, I group all of the parts together and then do the proper routing. So yeah, I will need to get rid of a bunch of routing from here, but then I can do the new routing, and then I'll have a controller. Espero asked 4-layer. Yeah, I expect so. I generally just, for anything beyond trivial boards these days, I normally just default to going 4-layer. It kind of makes things a whole lot easier. It is kind of like working on easy mode most of the time, because routing is just simpler. And the cost of the boards is not that significantly different, like not enough to care that much, because I'm not trying to optimize the price out of it. I'm only ever going to be making a few of these for myself, so like a 10-pack of boards will be plenty. Yeah, okay, so where are we? I've got to get back to the controls. Yeah, so I'm going to go and return a couple of calls, because I've had a couple of people, I've had 2 customers phone me while I've been doing this stream today. And so I've got to return a couple of calls and a few other things. And yeah, other stuff, lots of stuff to do today. So thanks for coming along. And if you're interested in the Squixel, check out Unexpected Maker. Really, really cool little device. I like these things. And be like Tassie Bob and buy one.
Outside the box said, Uru.
And because I said be like Tassie Bob and buy one, that means it's time to say goodbye. And thanks for coming to my TED Talk. And I will talk to you all really soon. Thanks. See ya.